If you remember back to the last thing that we talked about moles, atoms. Specifically, what we were doing is we were looking individually at elements, looking individual particles and things like that. Well, what we're going to do on this section is we're going to actually apply it now to compounds. Chemical formulas and the mole. Again, a chemical formula tells you two things. Number one, it tells you the elements that are present, and number two, it tells you the ratio that they are in. For example, if we're just talking about water, again, H2O. You're talking about hydrogen and oxygen, but also you're saying that it's in a ratio of 2 to 1. If you look at this example, CCl2F2, what we're saying is the elements that are present, carbon, chlorine, fluorine. But also the ratio that they're present in is going to be a 1 to 2 to 2 ratio. Knowing this information is going to allow us the ability to identify the number of moles of a particular element in a compound. So if I look at this one, it says determine the moles of aluminum ions Al3+ in 1.25 moles of aluminum oxide. The first thing you're going to have to do, as I have stated always, you have to write a correct chemical formula. So when I look at this or go to the periodic table, the thing is aluminum is in the +3 column. Oxide or oxygen is in the 2- column. So the proper chemical formula when you cross it is going to be Al2O3. Next thing you're going to do is you're going to go ahead and solve. What I do is I go ahead and I start off with my given. It tells me that I have 1.25 moles of the entire compound Al2O3. But the problem says what I want to do is I want to look for just that aluminum ion. So what I have to do is I have to look at this whole formula here. So I basically say I have one of the formulas, 1 mole of Al2O3. And now what I'm going to do is I'm going to look at just that aluminum ion. And when I look at just the aluminum ion, within this compound, or within that formula there, it's telling me that I have 2 of those aluminum particles. So when I go ahead and cancel out there, moles of compound cancel moles of compound, what I'm going to be left with is just that aluminum ion. So my final answer, when I take 1.25 times 2, I'm going to end up with 2.5 moles of the aluminum 3+ ion. Molar mass of a compound. Again, how did you find out how much 1 mole of an element massed or how much it weighed? You went to the periodic table. Well, the same thing is going to be done for a compound, but the only thing that we're going to have to do different is we're going to have to apply now those ratios. It says to find the molar mass of a compound, you just add up the masses of all of the elements in a compound, again taking into account those ratios for each element. So if I ask you to find the molar mass of K2CrO4, well, when I look there, again, we know the elements that are present are going to be potassium, chromium, oxygen. Again, potassium. In the formula, it says that there are 2 of them. You look up potassium on the periodic table, 39.1. When you multiply, potassium in this compound is going to weigh 78.2. Chromium, there's only 1 of them. Looking up the mass, 52, multiplying, I get a mass of 52. Oxygen, again, when I look at this formula, there's going to be 4 of them. 4 times 16, 64. And now what I'm going to do is basically make this one large addition symbol. Okay, I'm going to add 78.2, add 52, and add 64, and what that's going to tell me is the mass of the entire compound. So K2CrO4, or potassium chromate, is going to have a molar mass of 194.20. What that allows us to do is now start talking about moles of a compound using this molar mass. This is going to be very similar to what we did yesterday, okay? But now we're going to just be working with a compound. It says to convert 2.5 moles of C3H5 in parentheses 2S to grams. So I'm going to go ahead and start off with my given. 2.50 moles of the compound C3H5 2S. Again, to get something to cancel out, again, that mole is going to go on the bottom. So again, the compound C3H52S. And what we're going to do is we're going to put the grams on top of this compound, C3H52S. So off to the side here, let's go ahead and do our work. Carbon, when I look at that formula, there are 6 of them, times 12. That's going to be 72. Hydrogen, there are 10 of them, multiplied by 1.01, and I'm going to end up with 10.1. Sulfur, there's only 1 of them. Molar mass of sulfur, 32.1, so that's going to equal 32.1. And when I multiply throughout, I'm going to get a 2 there, 4 there, 10, 11, 114.2. So 114.2 is going to go there. Moles of the compound, cancel moles of the compound. When I take that 114.2 and I multiply it by 2.5, you're going to end up with an answer of 285.25 grams of C3H52S. Okay, so very similar to everything that we were doing yesterday, but now instead of elements, we're going to be using compounds. The final step is just going to be now taking the compound and converting it into an individual particle. Taking what you just learned at the beginning of today and applying it to what we did the other day. Here's a sample problem. It says that we have aluminum chloride has a mass of 35.6 grams. How many aluminum ions are present? How many chloride ions are present? And finally, what is the mass in grams of one formula unit of aluminum chloride? So let's go ahead and start off. Basically, this one and that one. They're really going to almost be the same type of problem. Now, before we really go on here, aluminum chloride, correct chemical formula, AlCl3. So again, we are going to start off with our given 35.6 grams of AlCl3. First thing we have to do is we have to convert it to moles. So 1 mole of AlCl3, when I add up aluminum, which is 27, I add in 3 of the chlorines, each one 35.5, I end up with 133.3 grams of AlCl3. Here's the thing, right now, if I stop here, I am in moles of the entire compound, but the problem says it wants us to go to ions. Well, before I go to ions, I need to get rid of that compound. So 1 mole of AlCl3. Now, when I look within that formula, how many are aluminum? Well, there's no subscript there, so there's only going to be 1 mole of that aluminum ion. So right now, I'm in moles of the aluminum ion. But the question says, how many ions is that? So I need to get rid of the moles of that aluminum ion. And again, if you remember from yesterday, I go ahead and I write up Avogadro's constant, 6.02 times 10 to the 23rd ions of aluminum. Moles of aluminum cancel moles of aluminum, so the only label that is left is going to be ions. When I take 35.6 multiplied by the 6.02 times 10 to the 23rd, dividing it by that molar mass of 133.3, I will end up with an answer of 1.61 times 10 to the 23rd ions of aluminum. So the first one's done. Now, here's the thing. The next question says how many chloride ions are going to be present? Well, here's the thing. This much of it right here almost stays the same. Okay? Those first 2 steps definitely stay the same. But if you notice, instead of looking at moles of the aluminum ion, what we want to do is we want to go ahead and actually look at moles of the chloride ion. So let's now go ahead and fix this problem. In this compound, okay, so right now we're in moles of the aluminum chloride molecule, okay, or formula. If I look up here, there's 3 chloride ions. So we're going to now have 3 moles of the chloride ion. 1 mole of the chloride ion is going to end up being 6.02 times 10 to the 23rd ions of that chloride ion. And now when I go ahead and solve it out, I'm going to take 35.6 multiplied by 3 multiplied by Avogadro's constant divided by that molar mass of 133.3, and what I'll end up with is 4.83 times 10 to the 23rd ions of that chloride ion. So in 35.6 grams of aluminum chloride, we're going to have 4.83 times 10 to the 23rd ions of chloride. Now for the last one, it says what is the mass in grams of one formula unit of aluminum chloride? So what we're going to be starting off with here is going to be 1 formula unit of AlCl3 Cl3. They're saying we have one individual particle, and I need to run that through to grams. This is almost exactly like what we did yesterday. Formula units are going to change to moles. So formula units of AlCl3, that's going to be 1 mole of AlCl3. And that's going to be that 6.02 times 10 to the 23rd. Again, formula units, that was one of those units that I told you that Avogadro's constant could be. Formula units, cancel formula units. Well, right now I'm in moles. But again, to get it to cancel out, 1 mole of AlCl3. We had it added up earlier, and we said that that was going to be 133.3 grams of AlCl3. Moles of aluminum chloride, cancel moles of aluminum chloride. When I run that through, really taking 133.3 divided by 6.02 times 10 to the 23rd, you end up with 2.21 times 10 to the negative 22 grams of aluminum chloride. It's not feasible to actually go back there and measure it, but the thing is we can calculate it out. One individual particle would weigh this much.